Hello viewers, welcome back. In this video, we'll discuss how to convert a relay logic into a PLC logic. Let's see a relay logic diagram. Here I have taken a dual circuit with the control logic from internet. I will not describe this diagram because you guys know about this, but from this diagram we can find out which one is the input and which one is the output. Here E stop is the input and overload also a input. Here E stop is a input, E start also a input, and all the coil here is the output. This KM auxiliary of this magnetic contactor as a input for monitoring the run feedback. This magnetic contactor is turned on or off. So for electrical run feedback we'll take this signal also. So from here we can say there is 5 input, 1, 2, 3, 4 and 5. If we take this LED in a PLC logic, so here are 3 output. So 1 for the magnetic conductor and 2 for the LED. So let's see how we can assign this IO. Here I have assigned this IO as 0.0 to 0.4 and output from 0.0 to 0.2. We can change this IO as your input or output module. Okay, let's see how we can wiring this input. Here we have take this input module. This is a basic input module. This input module, here there are 20 terminal, and this terminal, this one is 1 and this one is 8, and this from 1 to 8 terminal is a input from the input device, and terminal 9 and 10 is the spare, no connection. Terminal here 19 and 20 is the 19 is spare, 20 is for 0 volt from the power supply, and current will flow from the device to this input module. So this is a syncing input module. So what is in syncing and sourcing, you can watch my other video from the I button here. This is a outlook of the module. So we will take the input E stop at I 0.0 or I x.0. X can be 0 to 3 to 766. We can define 0, 2 or 3, anything. Okay. And channel 1 for overload, channel 2 for stop, start and run feedback from magnetic contactor. Okay, let's see the connection diagram for this input module. So this is a 24 volt bus from the 24 volt power supply, and here at terminal 20 we have to give 0 volt connection from this power supply. We have to give this. Any other connection or any 24 volt supply, no need. Only connection from the input device. E stop is the first input and 24 volt come from this E stop switch here to terminal 1, and from the overload 24 volt through this NC signal of overload relay to terminal 2. This is a I 0.1, and terminal 3 will give a channel 3 channel 2. This is a channel 2 and this is I 0.2 from the E stop switch, and here is the start switch. We can take it the 24 volt from 24 volt bus or after this stop signal. better to take it from here, because stop signal, if it is not there, so start switch will not give a input here. Otherwise you can say that you push the start switch but it is not run. Okay, and at the terminal 5, and that is I 0.4, will take the electrical feedback from this contactor, and contactor here 13 and 14. So from 24 volt will give a connection to terminal 13, and 14 will take the connection to terminal 5. Okay, let's see the output module. This is a basic module we will take in TI portal. That module has a 16 output in two group. So this group A, we have to give a power supply 0 volt connection at terminal 10 and 24 volt terminal at 9. 0 volt required to energize this module and 24 volt required for giving the output to output device. So if the logic is true, that time output will generate from to this terminal 1. If we connect output device at terminal 1, that device will energized. So if we required to make the connection at terminal 11, 12, 13, then we have to give 0 volt at 20 and 24 volt at 19. If we have no connection or no device, output device at terminal 11, 12, 13, then we no need to give 24 volt, or we can give like this, no issue. And here we will connect the run command at terminal 1 to magnetic contactor energize, and from the channel 1, that means terminal 2, will connect the LED for run indication, and from the terminal 3 will connect for fault module. So here see the wiring. From the terminal 1 will connect to the 24 volt magnetic contactor terminal A1, and at A2 will connect the 0 volt from the power supply, and terminal from 2 will connect to the run LED X1 positive, and here from X2 will connect the 0 volt of the power supply. Same way will connect here at terminal 3 for fault. Let's go to TI portal for the programming. Here I have take already digital input module and output module and configured this, because it need time to configure. You can watch my other video to check how to add and configure the digital input output module from this I button, right corner top. You can see from here that input address is taken 0 byte and 1 byte. You can assign 10, 20, no problem, but as I have shown in the diagram that we have take 0.0, so we will give start address 0.0. We can assign the tag here from here or from the PLC tag from here, but we can assign from here also like this. If we give a another input tag name like test, say I 0.5 is assigned for test bit. Okay, as like this we have assigned this 5 input, and also for output module we have configured this iOS 0.0 to 1.7. Also we can assign the tag from here, or from here we already assign. If you zoom it, then you can see the tag at the input address. So channel 0 it is stop, channel 1 it is overload, stop, start, and KM1 feedback, and channel 5 I have just write down that test bit, and at output terminal, output module, KM command and this is a running, and at channel 2 this is a fault. Now let's see how to make a logic. To make a logic, we have to go to program block. We can make the program at OB block, or we can make the program at function, then we have to call that function at OB1. Now we will make the logic at function block doll to PLC. Here you can take the function from here, add new block, click function, then give a name. By this way you can make a function, but I have take the function already. So here from this is a network and this is a called the run. Okay, we can take the instruction logic from here, instruction library, or we can take the instruction from here. Okay, we'll take the instruction from here. Okay, first I will take the output. Here is the output, our KM1 magnetic contactor command. So this contactor, when it will run, for now it will run directly, it will always run because this is a power rail. So power from here to this one directly, so we have to make a logic in between there. So first input is our E stop. So why E stop is a NO, this is a NO, this is a NC, normally close contact, this is a normally open contact. We have used the NC contact in E stop, but why here is NC? Because in physically NC contact 24 volt will give to our module when E stop is ready. So when 24 volt is in the input module, that means it is a logical 1. So when 24 volt is there, that means logical 1. So NO signal will be NC. So logically it will close. When E stop signal is ready, that time it will make a NC. Same way overload also a NC signal, and E stop signal also a NC signal, E stop signal. Now if those three signal is ready, that means NC condition normally closed in physical, then the from the power rail to output KM1 command will be activated, because all the logically is 1. So we have to make a command, until that command it will not energized. So we have to make a logic here that will make this KM1 command turn on or 0, turn off. So here I will give a start command here. So this start command physically it's a NO connection. So if this 3 input is ready, that time start signal normally without push it is a NO, so this one will not energized. So if this start is pushed, on this start switch is pushed, that time this will make the high, so your magnetic contactor will turn on. So push switch you have to release, so that time this one also be released, so this one will goes to 0 open, so this one will make released, that means off. So we have to make it hold. Here we can make here hold. So now here we'll make the hold by this command. Before we download, we'll make the logic for running indication and fault indication. So running indication we can make that Q 0.1 is for running, and this will run when this will on. Okay, so we have to make a fault logic here, because there are two types of fault. One is overload fault, another is feedback fault from the contactor. So here is the output fault, and that fault will generate from 2 when the overload is missed. That means if the overload is steep, that means it will goes to open, that means NC to NO. So when NO, that time 24 volt is not present at the input channel, so it is logical 0. But to make the fault, we have to make the power flow from this power rail to here. So it is possible only this contact is NC, because this signal is 0. So if we use here NC, then power come from here to there. Same way we have to make the fault when the command is generated but feedback is not came. Command is generated means this signal is 1. So power from here to here, when command is generated, that means this signal is 1. So this contact will be NC. So power from here to here is came here. So if the came feedback is not came from the contactor, that means 0 volt at the channel. So this signal is 0. So from power here to here came if it signal is NC, and we will wait for some time to came the signal from the contactor. So we have to wait here. So I will use a tune, and from this tune, when a specific time passed away, when this one is true, that time it will generate a fault. So I will give a 5-second wait. Okay, and when fault is generated, that time this command should withdrawn. So we have to make the logic with this command. So here I will make a logic here that when fault is not there, that means this is not energized, that means it is 0. So that time we have to make power from here to there. So it is only possible if this contact is NC. So here Q0.2 fault we have to take. Okay, and here we have to make the set, because we need to glow the LED. If the fault is generated here, that time this LED need to always glow. So it is possible by it set. So now we have to make this fault reset after the overload relay reset. Okay, or if the run feedback problem solve of magnetic contactor, that time we have to make the reset. So we have to give a reset here, and here is set, here we have to give a reset. How set and reset is work, you can watch my set reset video from this I button. Here Q0.2, and this fault means this fault is set here. So to reset we have to give the same address here. So here it will reset when we push reset button. For now we didn't make a wiring for this reset button. So if we make a wiring for reset button and assign an address like I0.5 and I0.5, so it is test. So I will rename it as a reset. Okay, this is logic for DOL relay logic to PLC logic. Okay, now download this program. I will hide this project window. then go to online mode, monitoring mode. This is now running LED is glow because I have forced it all the signal before. Now I will force it to 0 because I am giving a command stop. Now release it again. Okay, so release means it give a 24 volt because it's NC. If the stop overload is there, overload relay is activated, that means it gives it 0 volt to module, so fault will present. See here from the overload relay it's set. So after the overload relay reset from physical relays, now still the fault is there and fault LED should glow. This is the fault LED, it is glow. So here fault is there. So after reset, by push the reset button, it is now reset 0. I am releasing the push button, still signal is okay. Now I will force the start button to start the motor. Here I will force it to 1 means 24 volt to module. Again release it. Okay, it is holding. Okay, thank you for watching.